This is Physics 241 Lab. We're doing Lab 3 today, and today's lab has to do with the acceleration due to gravity. Remember when we did Lab 2, we dropped the picket fence through the photo gate, and hooking that photo gate up to a computer, we generated a graph, a V over T graph. And using the linear fit function of our Vernier software, we determined that the gravity of the picket fence going through the photo gate was 9.8 meters per second squared. That's the acceleration due to gravity. The question now is raised, does the size and or the shape of objects affect the gravity? Is it always 9.8 meters per second squared? Will different objects generate a different gravity, a different acceleration due to gravity? In this lab, what we're going to do is we're going to use a motion detector hooked up to our computer, and we're going to use that motion detector to generate V over T graphs again for different size balls, different weights, different constituencies, to see a couple of things. Now, what the hookup will be is on our table, we're going to have our hanger and we're going to have a motion detector suspended. We're going to put a ball underneath it and we're going to drop it to the ground. That'll be approximately a 3-foot drop. We're going to generate a V over T curve. It will be something like a sine wave. And using the linear fit function from our Vernier software, we're going to be able to determine the slope of that, the upward slope of that curve. And that slope will be the acceleration of that object, and it's the acceleration due to gravity. Now, the things that we're specifically going to look at are 4 different types of balls. We're going to have an air-filled 12-inch diameter ball. We're going to have a sealed 3-inch diameter tennis ball, air in the center. We're going to have a typical baseball about 3.5 inches in diameter with a hard center. And we're going to have a 2-inch diameter sealed racquetball. We're going to drop all 4 of those balls under the motion detector. We're going to generate the curve. We're going to use linear fit to determine the acceleration due to gravity of all 4 of these balls. And we're going to determine 2 things. Is their acceleration due to gravity in all 4 scenarios the same? And what will that be? Will it be 9.8 meters per second squared? Will it be a different number? Can we corroborate that in all 4 instances we're going to get the same gravity for all 4 balls?